Saturn, the sixth planet from our Sun, has captivated stargazers for centuries, ever since the renowned astronomer Galileo Galilei first observed it through his rudimentary telescope in the year 1610. Its mesmerizing rings, an ethereal halo of icy particles, set it apart from all other planets in our solar system, creating a spectacle that has fascinated both professional astronomers and casual observers alike. These rings are not solid structures, but rather a complex and intricate system of countless particles, each contributing to the overall grandeur of the rings. They are a breathtaking ballet of icy fragments, ranging in size from microscopic grains to massive boulders, each reflecting sunlight in a dazzling display that can be seen from great distances. The rings are incredibly thin, measuring less than a kilometer thick, yet they span an immense distance, stretching over 280,000 kilometers, which is more than twice the diameter of Saturn itself, creating a vast and delicate structure. To put that into perspective, that's almost the distance between the Earth and the Moon, a staggering scale that underscores the grandeur and magnificence of these celestial features. The rings are divided into distinct bands, separated by gaps known as divisions, the most famous of which is the Cassini division, named after the astronomer Giovanni Cassini, who discovered it in 1675, adding to the intricate beauty of the rings. These gaps are sculpted by the gravitational influence of Saturn's many moons, which shepherd the ring particles and create intricate patterns and waves within the rings, adding to the dynamic nature of this celestial phenomenon. The sight of Saturn's rings through a telescope is an awe-inspiring experience, revealing the delicate and complex nature of these structures and providing a glimpse into the wonders of our solar system. They are a testament to the raw beauty and power of the cosmos, a reminder of the dynamic and ever-changing nature of our solar system and the forces that shape it. These rings are more than just a celestial spectacle. They are a dynamic and ever-changing feature of our solar system, constantly influenced by the gravitational forces of Saturn and its moons and undergoing continuous transformation. Over time, the rings undergo subtle changes, with particles colliding, merging, and sometimes being ejected from the ring system altogether, illustrating the dynamic processes at play. Their origin, evolution, and eventual fate continue to intrigue scientists who study them to understand not only the history of Saturn, but also the processes that shape planetary ring systems throughout the universe, providing valuable insights into the nature of our cosmos. From the early observations by Galileo and Cassini to the detailed images captured by modern spacecraft like Cassini-Huygens, Saturn's rings have been a focal point of astronomical research and discovery, contributing significantly to our understanding of the universe. The Cassini mission, which orbited Saturn from 2004 to 2017, provided unprecedented insights into the composition and behavior of the rings, revealing their complexity and the dynamic interactions within them, and greatly enhancing our knowledge of this magnificent planet. The origin of Saturn's rings remains a topic of debate, with theories suggesting they could be remnants of a destroyed moon or the primordial material from which Saturn itself formed, adding to the mystery and allure of these celestial features. Composed primarily of water ice with traces of rocky material, the rings reflect sunlight brilliantly, making them one of the most striking features in our solar system and a subject of endless fascination. The study of Saturn's rings not only helps us understand the planet itself, but also provides clues about the formation and evolution of planetary systems beyond our own, offering a window into the processes that shape the cosmos. As we continue to explore and learn more about these majestic rings, they remain a symbol of the beauty and mystery that lies beyond our world, inviting us to look up and wonder, and to seek answers to the many questions that still remain. Saturn's rings are a dazzling display of cosmic artistry, a celestial phenomenon that has fascinated astronomers and stargazers alike for centuries. These rings are not just beautiful to look at. They hold a wealth of information about the processes and materials that exist in our solar system. These magnificent rings are composed primarily of water ice, with trace amounts of rock and dust interspersed throughout their structure. The water ice gives the rings their bright, reflective quality, while the rock and dust add complexity and variation to their appearance. The ice particles that make up the rings are believed to have originated from a variety of sources, including comets, asteroids, and even moons that were captured by Saturn's gravitational pull. These celestial bodies, once part of the vast expanse of space, were drawn into Saturn's orbit by its immense gravitational force. Upon being captured by Saturn's gravity, these bodies were subjected to intense tidal forces that caused them to break apart. This process, known as tidal disruption, resulted in the creation of countless fragments that now make up the rings. These fragments, unable to escape the planet's gravitational grip, became trapped in orbit around Saturn. Over time, they coalesced to form the stunning rings we observe today. This process of ring formation is a dynamic and ongoing one, with new material constantly being added and old material being lost. It's important to note that the composition of Saturn's rings is not uniform. It varies significantly from one section to another. This variation is due to the different sources of material and the different processes that have shaped the rings over time. For instance, the inner rings, which are situated closer to Saturn, contain a higher proportion of rocky material. This is likely due to the fact that the inner rings are more affected by Saturn's gravity, which can cause denser, rockier material to accumulate there. This higher concentration of rocky material gives the inner rings a slightly darker appearance when compared to the outer rings. The outer rings, being farther from Saturn, are less affected by its gravity and therefore contain more pristine water ice. In contrast, the outer rings are predominantly composed of pristine water ice, which is why they exhibit a brilliant sheen that is easily visible even from great distances. This ice is thought to be relatively pure, with few impurities to dull its reflective quality. This reflective quality of the outer rings is one of their most striking features, contributing to their characteristic brilliance. The ice particles in the outer rings reflect sunlight, making them shine brightly against the dark backdrop of space. Another fascinating aspect of Saturn's rings is the variation in the size of the particles that comprise them. This variation is a result of the different processes that have contributed to the formation of the rings, as well as the ongoing interactions between the particles. Some of these particles are as minuscule as dust grains, barely visible to the naked eye. These tiny particles are thought to be the result of collisions between larger particles, which break apart into smaller fragments. On the other end of the spectrum, there are particles as large as houses, creating a diverse and dynamic environment within the rings. These larger particles are likely remnants of the original celestial bodies that were captured by Saturn's gravity. This incredible diversity in particle size and composition is what gives Saturn's rings their intricate structure and mesmerizing appearance. The rings are constantly changing, with particles colliding, breaking apart, and reforming, creating a dynamic and ever-evolving system. This makes them one of the most captivating features in our solar system, a testament to the complex and beautiful processes that shape our universe. As breathtaking and awe-inspiring as Saturn's rings are, it is important to understand that they are not eternal. These rings, which have fascinated humanity for centuries, are in a state of gradual decline. These magnificent rings are slowly but surely disappearing, a process that is both fascinating and melancholic. The very forces that created these rings are now contributing to their demise. This cosmic erosion, which is gradually wearing away the rings, is driven by several interrelated factors. Understanding these factors requires a deep dive into the complex interactions within Saturn's environment. One significant factor contributing to this decay is the constant bombardment of micrometeoroids and solar radiation. These tiny particles, often no larger than grains of sand, travel through space at incredible speeds. These relentless particles chip away at the icy ring particles, grinding them down over time, much like sandpaper on wood. This process, known as sputtering, gradually reduces the size and mass of the ring particles. Another contributing factor to the ring's gradual disappearance is Saturn's powerful magnetic field. This magnetic field, which is generated by the planet's rapid rotation and metallic hydrogen core, extends far into space. This magnetic field interacts with the charged particles within the rings, causing them to spiral inwards towards the planet in a slow but steady dance. This process, known as magnetospheric drag, pulls the particles closer to Saturn. As these particles make their way into Saturn's atmosphere, they burn up, creating a faint but detectable glow that can be observed by scientists. This phenomenon, known as ring rain, is a clear indicator of the ring's ongoing erosion. Scientists have estimated that Saturn's rings are losing material at an alarming and rapid rate, a phenomenon that has captured the attention of astronomers worldwide. The rate of loss is so significant that it has prompted numerous studies and observations. Based on detailed observations from the Cassini mission, it is believed that the rings could be completely gone in as little as 100 million years, a relatively short period in the grand scheme of the universe. The Cassini spacecraft provided invaluable data that has deepened our understanding of this process. While 100 million years may seem like an eternity to us, it is merely a blink of an eye in cosmic terms, a fleeting moment in the vast timeline of the universe. This perspective highlights the transient nature of even the most majestic celestial phenomena. The ongoing study of Saturn's rings not only enhances our understanding of the planet itself, but also provides insights into the dynamic processes that shape our solar system. As scientists continue to unravel the mysteries of these rings, we gain a deeper appreciation for the delicate balance of forces that govern the cosmos. In the grand tapestry of the universe, Saturn's rings are a beautiful yet ephemeral feature, reminding us of the ever-changing nature of the cosmos. Their eventual disappearance will mark the end of an era, but also the beginning of new discoveries and understandings in the field of astronomy. Our understanding of Saturn's rings has been profoundly revolutionized by the groundbreaking Cassini-Huygens mission, which has provided us with a wealth of data and insights that were previously unimaginable. This ambitious and highly collaborative mission, which was a joint effort between NASA, the European Space Agency, and the Italian Space Agency, spent over a decade meticulously exploring Saturn and its numerous moons. The mission's success was a testament to international cooperation and the relentless pursuit of scientific knowledge. Cassini's sophisticated instruments provided us with unprecedented and highly detailed views of the rings, revealing their intricate structure and dynamic behavior in astonishing and previously unseen detail. These instruments included powerful cameras, spectrometers, and radar systems that allowed scientists to study the rings in multiple wavelengths of light. The spacecraft made several groundbreaking discoveries, including the identification of new rings, the discovery of additional moons, and even the detection of lakes of liquid methane on Titan, which is Saturn's largest moon. These findings have significantly expanded our understanding of the Saturnian system and its complex dynamics. One of Cassini's most significant and intriguing discoveries was the detection of a phenomenon known as ring rain. This discovery was made possible by the spacecraft's ability to measure the composition and behavior of particles within the rings. This fascinating phenomenon occurs as charged water molecules from the rings are pulled into Saturn's atmosphere along the planet's magnetic field lines, creating a unique interaction. The process is driven by the planet's strong magnetic field, which acts like a giant funnel, channeling particles from the rings into the upper atmosphere. This ring rain carries not only water, but also organic molecules from the rings into the planet's upper atmosphere, contributing to a complex and dynamic interaction between Saturn's rings and its atmosphere. These interactions have important implications for our understanding of the planet's atmospheric chemistry and the life cycle of its rings. The Cassini mission culminated in a dramatic and scientifically rich grand finale, where the spacecraft made a series of daring dives between Saturn and its rings, providing even more valuable data before its mission concluded. This grand finale was designed to maximize the scientific return of the mission, allowing scientists to gather data from regions that had never been explored before. During its final orbits, Cassini transmitted a treasure trove of data back to Earth, including detailed measurements of Saturn's gravity and magnetic fields, as well as high-resolution images of the planet's atmosphere and rings. This data continues to be analyzed by scientists, yielding new discoveries and insights long after the mission's end. The legacy of the Cassini mission is profound, as it has fundamentally changed our understanding of Saturn and its rings. The mission's findings have inspired a new generation of scientists and have set the stage for future exploration of the outer solar system. Section 5. Ring Rain, a cosmic shower, shaping Saturn's atmosphere. Ring rain is a truly fascinating and intricate example of the interconnectedness of planetary systems, showcasing the delicate balance and complex interactions that occur within our solar system. This phenomenon is not just a simple occurrence, but a testament to the dynamic processes that govern planetary bodies and their environments. This cosmic shower, which was first detected and meticulously studied by the Cassini mission, plays a significant and influential role in shaping the atmospheric conditions of Saturn. The Cassini spacecraft, which orbited Saturn for over 13 years, provided unprecedented data that allowed scientists to understand the intricate details of this ring rain. As charged water molecules from the rings descend and rain down into the planet's upper atmosphere, they engage in interactions with the various atmospheric gases present. These interactions are complex and involve a series of chemical reactions that are crucial for understanding the atmospheric dynamics of Saturn. This interaction results in the creation of a complex and dynamic chemical cocktail, which significantly influences both the composition and the temperature of Saturn's atmosphere. The charged water molecules, upon entering the atmosphere, react with hydrogen and other gases, leading to the formation of new compounds and altering the thermal structure of the atmosphere. The continuous influx of water from this ring rain phenomenon is thought to be responsible for depleting the abundance of certain key molecules in Saturn's upper atmosphere, leading to notable changes. For instance, the presence of water can lead to the reduction of methane and other hydrocarbons, which are essential components of the atmospheric chemistry. The detailed study of ring rain provides invaluable insights into the evolution of planetary atmospheres, shedding light on the complex interplay between a planet and its rings over time. By analyzing the data from Cassini, scientists can trace the history of Saturn's atmosphere and predict future changes, offering a window into the past and future of planetary evolution. It highlights the dynamic and ever-changing nature of our solar system, emphasizing the intricate and ongoing processes that shape the celestial bodies within it. The phenomenon of ring rain is a reminder of the constant state of flux in our solar system, where even the seemingly stable rings of Saturn are actively contributing to the planet's atmospheric dynamics. Section 6. The life cycle of Saturn's rings, from formation to disappearance. The story of Saturn's rings is one of birth, evolution, and eventual demise, a cosmic tale that spans millions of years, encapsulating the dynamic processes that govern our universe. While their exact origin remains a subject of debate among scientists, the prevailing theory suggests that they formed from the remnants of shattered moons, comets, or asteroids. These celestial bodies, once robust and whole, roamed the vast expanse of space before meeting their fate. These celestial bodies, once captured by Saturn's immense gravitational pull, were torn apart by the powerful tidal forces exerted by the planet. The immense gravitational forces of Saturn, are capable of ripping apart these bodies, a process known as tidal disruption. The resulting debris, a chaotic mix of ice, rock, and dust, eventually settled into orbit around the planet. Over time, these fragments coalesced, forming the magnificent rings we see today, a testament to the planet's gravitational mastery. Over the course of millions of years, the rings have undergone significant evolution. They are continuously shaped and reshaped by the gravitational influence of Saturn's numerous moons, which tug and pull at the rings, creating waves and gaps. Additionally, the constant bombardment of micrometeoroids plays a crucial role in this ongoing transformation. However, this relentless process of erosion, caused by the incessant impacts of micrometeoroids, is gradually wearing them down. These tiny particles, traveling at high velocities, chip away at the ice and rock, slowly but surely diminishing the ring's mass and altering their structure. Scientists estimate that Saturn's rings are relatively young in cosmic terms, perhaps only 100 million years old. This is a mere blink of an eye in the grand timeline of the universe, suggesting that the rings are a relatively recent addition to Saturn's majestic presence. This suggests that we are witnessing them in their middle age, a stage where they are neither in their infancy nor approaching their end. Instead, they are in a period of dynamic change, constantly evolving and adapting to the forces acting upon them. Eventually, the relentless forces of gravity and erosion will take their toll. The gravitational interactions with Saturn's moons and the continuous impact of micrometeoroids will gradually dismantle the rings piece by piece, leading to their inevitable decline. The rings will eventually fade away, leaving behind only a faint trace of their former glory. This ghostly reminder will serve as a testament to the dynamic and ever-changing nature of our cosmos, a silent witness to the forces that shape the universe. Section 7. A universe of rings, comparing Saturn to its gaseous neighbors. Saturn, the sixth planet from the Sun, is not the only celestial body in our solar system adorned with rings. These rings are composed of countless particles, ranging in size from tiny dust grains to large boulders, all orbiting the planet in a delicate balance. In fact, Jupiter, Uranus, and Neptune also possess ring systems, each with its own unique characteristics and features. These rings vary greatly in terms of their composition, structure, and visibility, offering a fascinating glimpse into the diverse nature of our solar system. However, when we compare these ring systems, it becomes evident that Saturn's rings are by far the most prominent and awe-inspiring. Saturn's rings are composed primarily of water ice, with traces of rocky material, and they span an impressive 282,000 kilometers in diameter. This vast expanse of shimmering ice particles captures the imagination of astronomers and stargazers alike. Jupiter's rings, for instance, are faint and dusty, likely formed from material ejected by its moons. These rings are composed mainly of small, dark particles that reflect very little sunlight, making them difficult to observe without powerful telescopes. The material in Jupiter's rings is thought to originate from micrometeoroid impacts on its moons, which eject dust and debris into orbit around the planet. Uranus's rings, on the other hand, are dark and narrow, composed of large, icy chunks. These rings are quite different in appearance and composition compared to those of Saturn. The rings of Uranus are believed to be relatively young, possibly formed from the remnants of a moon that was shattered by a collision. The dark coloration of Uranus's rings is thought to be due to the presence of radiation-processed organic material. Neptune's rings are clumpy and uneven, suggesting they are relatively young in the grand timeline of our solar system. The clumpiness indicates that these rings might still be evolving, with gravitational interactions and collisions continuously shaping their structure. Neptune's rings are composed of a mixture of ice and dark organic material, and their uneven distribution hints at the dynamic processes at work in the planet's ring system. The diversity of ring systems in our solar system highlights the dynamic nature of planetary formation and evolution. Each ring system provides valuable insights into the processes that shaped these giant planets. By studying the composition, structure, and behavior of these rings, scientists can learn more about the history and evolution of the planets they encircle. Each ring system tells a unique story about the history of its host planet, offering clues about past collisions, moon interactions, and the gravitational forces at play. The study of these rings continues to be a fascinating field of research in planetary science, revealing the complex and dynamic nature of our solar system. Through ongoing observations and missions, we hope to uncover even more secrets about these enigmatic structures and the planets they surround. Section 8. Probing the Cosmos. Unveiling Saturn's secrets through technology. Our ever-expanding understanding of Saturn's magnificent rings has been made possible by the relentless ingenuity and tireless efforts of scientists and engineers. These brilliant minds have developed increasingly sophisticated telescopes and spacecraft, pushing the boundaries of what we know. The journey to uncover Saturn's secrets is a testament to human curiosity and technological advancement. Ground-based telescopes, equipped with state-of-the-art adaptive optics to compensate for atmospheric distortion, provide stunning and breathtaking views of Saturn's rings from the comfort of our own planet, Earth. Adaptive optics technology corrects the blurring effects of Earth's atmosphere in real time, allowing astronomers to capture images with remarkable clarity. Spacecraft like the iconic Voyager 1 and 2, the groundbreaking Cassini-Huygens mission, and the ever-vigilant Hubble Space Telescope have revolutionized our understanding of Saturn and its intricate ring system. The Voyager missions, launched in the late 1970s, provided the first close-up images of Saturn, revealing the complexity and beauty of its rings. These ambitious missions have provided us with close-up images of unparalleled clarity, detailed spectroscopic data, and a wealth of other valuable information. Spectroscopy, the study of how matter interacts with electromagnetic radiation, has been crucial in analyzing the composition of Saturn's rings. This treasure trove of data has allowed scientists to meticulously study the composition, structure, and dynamic behavior of the rings in unprecedented detail. Looking ahead, future missions, such as NASA's highly anticipated Dragonfly mission to Titan, promise to further unravel the myriad mysteries of Saturn and its enigmatic rings. The Dragonfly mission, set to launch in the mid-2020s, aims to explore Titan's surface and atmosphere using a rotorcraft lander. These missions hold the potential to unlock new secrets and deepen our understanding of this fascinating celestial body. The continuous advancements in space technology and exploration ensure that our quest to understand Saturn and its rings will persist, revealing new insights and expanding our knowledge of the universe. Section 9. Saturn's enigmatic future, unanswered questions and daring missions. Despite all that we have learned about Saturn and its rings, many questions remain unanswered, leaving scientists and astronomers with a sense of wonder and curiosity. The more we discover, the more we realize how much there is yet to understand. How exactly did the rings form? This question has puzzled researchers for decades, as the origins of these magnificent structures are still shrouded in mystery. Some theories suggest that the rings could be remnants of a moon that was torn apart by Saturn's gravity, while others propose that they might be leftover material from the planet's formation. What is the precise composition of the ring particles? Understanding the exact materials that make up the rings could provide crucial insights into their formation and evolution. The rings are primarily composed of water ice, but they also contain rock and dust particles. Determining the proportions and origins of these materials is key to unraveling the history of the rings. How do the rings interact with Saturn's atmosphere and magnetic field? The dynamic relationship between the rings and the planet's atmospheric and magnetic properties is a complex puzzle that scientists are eager to solve. The rings are influenced by Saturn's gravity and magnetic field, which in turn affect the planet's atmosphere. This interplay could reveal new information about the planet's internal structure and the behavior of its magnetic field. To answer these questions and more, scientists are planning daring new missions to Saturn, aiming to uncover the secrets that have eluded us for so long. These missions will involve advanced technology and innovative approaches to explore the planet and its rings in unprecedented detail. NASA's Dragonfly mission, set to launch in the 2030s, will explore Titan, Saturn's largest moon, searching for signs of life and studying its methane-rich atmosphere. This ambitious mission will provide unprecedented data and potentially groundbreaking discoveries. Titan's thick atmosphere and surface lakes of liquid methane make it a unique and intriguing target for exploration. These missions will undoubtedly reveal new wonders and deepen our understanding of this captivating planet and its ethereal rings, expanding our knowledge and inspiring future generations of scientists and explorers. The data collected will help us piece together the history of Saturn and its rings, shedding light on the processes that have shaped our solar system. Section 10. The enduring allure of Saturn inspiring wonder for generations to come. Saturn, with its mesmerizing and intricate rings, has captivated the imagination and curiosity of humanity for centuries, drawing the eyes of astronomers and dreamers alike. These rings, composed of countless particles of ice and rock, create a spectacle that is both scientifically fascinating and visually stunning. It stands as a symbol of the vastness and unparalleled beauty of the cosmos, a celestial reminder of the countless wonders and mysteries that lie beyond our world, waiting to be discovered. The rings themselves are a testament to the dynamic and ever-changing nature of our solar system, offering clues about the processes that shape planetary bodies. The study of Saturn's rings is not merely about unraveling the secrets of a distant and enigmatic planet. It involves understanding the complex gravitational interactions that govern their structure and behavior, as well as the history of their formation and evolution over time. It is about pushing the boundaries of human knowledge and understanding, inspiring future generations of scientists, engineers, and explorers to reach for the stars and beyond. By studying Saturn and its rings, we gain insights into the fundamental principles of physics and astronomy that apply to the entire universe. As we continue to explore our solar system and the vast expanse beyond, Saturn's rings will undoubtedly continue to inspire awe, wonder, and a sense of adventure for generations to come, reminding us of the endless possibilities that await in the universe. The legacy of Saturn's rings is not just in their beauty, but in their ability to ignite the spark of curiosity and the drive for discovery in the hearts and minds of people across the globe. From the early astronomers who first glimpsed Saturn through rudimentary telescopes to the modern-day scientists utilizing advanced technology to probe its secrets, the journey of exploration continues. Each new discovery about Saturn and its rings adds another piece to the puzzle of our understanding of the cosmos. The future holds the promise of even more profound discoveries, as new generations of explorers and innovators build on the knowledge of those who came before. Saturn's rings will remain a beacon of inspiration, guiding humanity's quest to uncover the mysteries of the universe and our place within it.